This is Geometry Unit 8, Lesson 4, Working with Similar Triangles. What we're going to be looking at is when triangles are similar and the properties that we can use to help us figure out sides and angles of the triangles. So let's try our first example here. In the diagram, we have PQ is parallel to AB. So this segment PQ is parallel to AB. What I want to know is if the big triangle ABC, which is right here, is similar to PQC, which is this triangle right here. So the small triangle inside the big triangle. Are they similar? Well, what's the simplest way to prove similar? Probably use angle-angle. Let's see if we can prove angle-angle. Now, if we know these lines are parallel, do we know if any angles are congruent? Well, how about angle P and angle A? What kind of angles are those? Angle P is congruent to angle A because they're corresponding angles. If lines are parallel, corresponding angles are congruent. So we know that angle P is congruent to angle A. All right, now, is there another pair of angles that we could use? Well, couldn't we say the same thing about angle Q and angle B right here? Aren't they also corresponding angles? They are. Corresponding angles are congruent, so therefore we've got two pairs of angles. So that means triangle ABC is similar to triangle PQC by angle-angle similarity. We proved two pairs of corresponding angles are congruent. Now we could actually even say that C is congruent to C because that's reflexive. It's the same angle in both triangles. But just getting these two was fine. All right, so now that we know that these two triangles are similar, we can actually find the values of X and Y using the two triangles. When you're doing a problem like this, the first thing that you want to do is draw yourself a picture. So the two triangles that I'm going to draw are PQC and ABC. So here's my little triangle PQC and my big triangle ABC. I'm going to draw them out separately because that really helps me see what sides I have and what sides I don't. Now, PQC was this triangle on top. All right, so if we fill in the values that we have, we know that this was 6, this was 8, and this was 9. Okay, so this is 6, this is 8, and this is 9. All right, now for the other triangle, this is where it gets a little bit tricky. We have to know what ABC is. All right, we're looking for AB is X. So that was this side up here. This is X right here. Okay, now what is the length of BC? What's the length right here? Well, that whole side would be the sum of these two. So this would actually be y plus 8. And what would be the length of AC? Well, AC would be the length here. This would be 10. So when you draw the triangles out separately, you can see immediately that this side is going to be 10 and this side is going to be y plus 8. All right, now since we know the triangles are similar, the sides are in proportion. All right, so all the sides are in proportion. That means they have the same ratio. So what we need to do is figure out a pair of sides that we know correspond, that have both values, and then the one we don't. So let's do the X one first. All right, so the one that has X in it is AB. There's X right there is AB. What side in the smaller triangle does AB correspond to? Well, according to what we have for our similarity statement, AB would be similar to PQ right here. So PQ would be here. So when I set up my ratio, I'm going to say AB is to PQ. All right, now I need a pair of sides that I know for sure. In the other triangle, in the same triangles, I need a pair of sides, values for both sides. What pair of sides that correspond are they both, do we have both values for? Well, in the bigger triangle, since AB came from this triangle, what side do we have in this triangle and this triangle? So that would be AC. All right, what side does AC correspond to in the smaller triangle? It would be PC, right there. So AB is to PQ as AC is to PC. Now let's plug in our values and we can find X. AB is to PQ, AB is X, PQ is 9. AC is 10, and PC is 6. Now that I've got my proportion, I just have to cross multiply. So 6x is equal to 9 times 10 is 90. Divide by 6. and that gives me x is equal to 15. So that means that AB is 15. Now, since the sides are in proportion, I can do the same thing for the side that has y in it. I just have to use one value that I know for sure. Now, I knew that PC and AC were for sure, so I'm going to use those again. AC is to PC. Now, out of this triangle AC, the one that has y on it is BC. So that's going to go on top. And what side does BC correspond to? In the other triangle, here's BC. Whoops, that's pretty bad. BC corresponds to QC. So BC is to QC. Notice, same triangle, same triangle, same triangle, same triangle, same order. You can do them any order you want, just make sure you're consistent. All right, so we knew AC and PC, we know were 10 and 6. Now BC is y plus 8, and QC, the corresponding side to it, is 8. All right, now when I cross multiply, remember that this is a binomial, so when I multiply, I really have to do 6 times y plus 8 is equal to 80 when I cross multiply. So that's 6y plus 48, don't forget to distribute. Subtract the 48, that gives you 6y is equal to 32. And then divide by 6, and y is equal to 5.33. 5.33 repeating it actually comes out to be. So that means the value of y is 5.33. So x is 15, y is 5.33. It's really important when you do these to draw yourself a diagram so you can see exactly what sides correspond when you set up your proportion. Now let's try this problem. Amber stands up on stage trying out for a role in a play. A footlight shines on her from 8 feet in front of her. 6 feet behind her is a tall light-colored backdrop. If Amber is 5 feet 8 inches tall, how tall is her shadow on the backdrop? Okay, diagram is vitally important in this. So all of this is based on Amber standing on stage. So we need to draw Amber. So here is Amber standing up on stage. That's Amber. She has a footlight shining on her from 8 feet in front of her. So in front of her, she's standing facing this way. So 8 feet in front of her like this is a footlight, is right here. So this distance right here is 8 feet. Now, also 6 feet behind her is a tall light-colored backdrop. So if she's standing here, behind her, 6 feet, this distance would be a backdrop standing up. So the backdrop is tall, it's taller than she is, like this. So that's how high it is. Hopefully it's standing straight up and down or else it'll be leaning. All right, now, Amber is 5 feet 8 inches tall. How tall is her shadow in the backdrop? Now remember, if the footlight is standing here, the light would go up like this, shining up above her, and it would be reflected onto the backdrop here. So her shadow would actually be on this wall. So this wall right here would be, the whole thing would be her shadow. So that's going to be my x. That's how tall the shadow is. Okay, now do you see two similar triangles? I do. I see one here and I see the big one as well. So I'm going to draw them out separately. So I have the small triangle. Let me do it back to solid here. My small triangle like this. And my bigger triangle for the whole value. Okay, so let's fill in the values for the smaller triangle. We have 8 feet here, and we have Amber is 5 feet 8 inches. Okay, now that's a little clunky because we have two different units there. It's a lot easier to work this out if it's one unit. So I'm going to make this all inches. 5 feet is 60 inches. So if 5 feet is 60 inches, that means that Amber is actually 68 inches tall. Okay, now what I do when I set up my other ratio, or my other triangle, I want to make sure that my units up here, x, is also going to be in inches. All right, now here's my other question. How far is it from here to here? What's the length from there to there? This length right here is actually 14 feet. So that's my comparison of my two triangles. Now, let's set up our ratio. We want the corresponding sides to be in proportion. Now make sure, whatever ratio you write, you have the same units. So I'm going to compare my bottom value here, 8 feet to 14 feet. And then I want to compare my heights. This is 8 feet, this is 68 inches tall. And then this height is going to be x. Now I have to keep in mind when I solve this, this is also going to be in inches. As long as your ratio is set up with the same units, you can do this. These are both feet, these are both inches. You just have to remember what units you solve for when you're done. All right, cross multiply, you get 8x is equal to 14 times 68, which is 952. And then divide by 8, and x is equal to 119. Now, since this is x units, what units is this in? Well, this is 119 inches. So, this value of x is 119 inches tall. That's how tall her shadow is. Now, if you wanted to figure out how tall this is in feet, you just divide this by 12. But for our purposes, this works out well. So it would be, divide this by 12, it's going to be about 9 feet, and it's be 108. So 12 times 9 is 108, so that would be 9 feet and about 11 inches. So leaving it in inches is just fine, unless you're asked specifically to find the feet. So this is 119 inches is a fine answer. Okay, so the important part about doing these problems is be able to draw your diagram and draw the triangles out separately. It's very, very important so you can see what values you have.